here's the subtraction problem. 4,259 minus 2,171.
So the purpose and the objective of the lesson was for the kids to have a chance to explore subtraction.
And what I want you to do is figure out, what are these tape diagrams saying, and which one is modeling this problem correctly?
The students had the opportunity to keep working on the standard throughout the entire lesson as they explored tape diagrams in different settings. When I learned mathematics, I learned a process, and I never really understood what that process meant. And through the Common Core learning standards and through the trainings that I've gone to in order to become a better teacher of mathematics, I've started to look at math in a different way.
So you subtract. No, because the end's in the bottom, and when it's in the bottom, you add.
So you think the first one is saying what to you?
You're adding.
You're adding. Matt, how do you know that it's telling you to add?
Because when you have the two numbers right there and the ends down there, it just says to me that you're supposed to add.
It says you're supposed to add and look for your whole. So then what about down here? We've got two that don't have the n as a whole. So what do we think?
They both mean subtract because you have to subtract 2,171 from 4,259 to figure out what the n is.
Okay. So you think the correct one is this one, Arian?
What do you mean by correct?
Which one do you think represents this problem? Because only one of these three is correct.
So what made you think that?
So what makes you think? She's thinking both of them could possibly be correct, but only one of them is correct.
Like what you just said. We just said it's gotta make sense because 2,171 is
Think about our pumpkin problem. Okay, think back to the pumpkin problem. How many did we start with? What was our whole?
15.
Okay. What are we starting with in this problem?
4,259.
So which problem then, which tape diagram do you think is accurate?
This one?
Which one shows our starting point?
well, actually we should.
Oh, this one.
And I showed them the tape diagrams, and they had a little bit more difficulty with that, trying to recognize the tape diagram that was appropriate. And that was a good learning experience for them as we were trying to talk about the whole and where the whole comes from in a subtraction problem.
Let's bring it back together and have a discussion together. This first one right here, where it says 4,259, 2,171, and n is here, can someone raise your hand and tell me, what is that saying to you? What does that say to you? Ryan, what does that one say to you?
It's saying that you need to add them two to find out the whole.
Okay, and is that what I'm asking you to do
No.
in this problem?
It says 4,259 minus 2,171.
Okay, so I'm going to cross this one out. It cannot be that one because that one's modeling addition, okay? So that leaves us with these two problems. Only one of them is right. This is where it gets a little tricky. Which one of these tape diagrams is showing to me 4,259, I had that, and then I took away 2,171. Which one's showing that to me, Tegan?
The one that's showing it to you is the last one.
Why do you think that?
Because it shows that the whole is 4,259 and that one of the parts is 2,171.
Okay, with your group, I want you to solve the actual problem. Go ahead and solve it. Model it and solve it. And I'm going to walk around and talk with you. Yep, on that next page where it says 4,259 minus 2,171. Work together and solve it.
With their work where they were in their groups, they were able to use that same format again of using the tape diagram to help them solve the subtraction word problem that they had to accomplish and finish.
And then you have to split the bar model in half, or however you want to split it.
Yeah, and you want to try to make one bigger than the other.
Yeah.
One just a little.
Yeah,
not
just
too
a little
much.
bigger, but not.
Yeah, put like 2,171 in the smart part, and then
just cut it in the middle, but
and
make it
in the big part.
You could just cut it in the middle, but then you just make it you put it over a little bit more, like maybe
scooch
like
it
a
over.
few inches more.
I think we should put N in the other part
Because we don't know that part. And then to solve it, you guys know what we're supposed to do, right? Just subtract.
Yeah.
Pretty simple.
We have to make the one that equals the whole a little bit smaller.
I think we should leave it the same way because 2,688 is a little bit, is like bigger than 2,171.
So Ryan, you're saying you would want to move your bar over to show that this number is smaller than that?
Yeah.
That makes sense. You could definitely do that.
The whole bar model and then split it in half.
You could do that too to show that you understand the value of the number. That's okay.
It seems like to me we have a pretty good handle on this right now. Question, what was the answer to the problem when you actually subtracted? Everyone did a fantastic job modeling as I was walking around and checking in with you and listening to your explanations. What was the answer to the problem? What did you come up with, Jack?
First, me and Bradley first for our bar model, we put 2,171 in the half of the bar model.
I put rigor into my lesson by having them explain their mathematical reasoning and also to explain how they could check their answer. Being able to actually write out a response in mathematics can be pretty rigorous because it's something that they're not used to doing yet. Another way that I put rigor into the lesson was by having a multi-leveled activity so that I could challenge the kids who needed a challenge and to bring it back down for some of the other kids who might needed to look at it a little bit more closely.
And then we had to subtract 4,259 from 2,171 because those are our two parts. And we got 2,088. And then to check, we did 2,177 plus our new number that we got, 2,088, and we're going to be solved. And we got the right number, 4,259.
We're no longer teaching our students the tricks anymore to math. We're actually having them think about it and apply it. And I think that this lesson really lended itself to that. The kids not only had an opportunity to explore using the tape diagram to model their mathematics, but you saw many of them relying on their vertical number lines to show how they were coming up with their rounding and estimations to check the reasonableness of their answer. So I think that this lesson really shows the modeling and how teachers can be implementing modeling in their classroom to help with the Common Core shifts.
All right, so first, let's make the 3 lines. All right, this will be the missing number.
Scooch a little closer to me.
And that's Susie, so... Wait, what number are you doing?
All right, Bradley, do what he needs to do. He's got
Susie.
And then I gotta put in
1,349.
That's Lucy.
So we gotta do hey, let me. Okay. 1,300. Wait, it's 1,349. So 49. And then for the whole.
And then we have that number. So the whole is 6,976. And then for the solution sentence, Becky has
blank cards. So Becky has blank cards. Okay. So next, what we'll have to do
And solve.
Yes.
With the Common Core in mathematics, the students, as they're coming through the grades, are going to have a much stronger number sense because of the ways that they're thinking and talking and modeling mathematics in their classrooms. The math conversations that we're having now with the Common Core are just allowing the kids to dive into this really deep understanding, to really explore these things and to challenge each other and to challenge each other's thinking. That's when the deep understanding starts to occur in the classroom.